Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farhan bin Akbar Shah. Matric number AA170701. Group members with Muhammad Haziq and Muhammad Fahmi. As for the start of the second assignment, industrial electronic subject, I will talk about the introduction. Ladder diagrams are specialized schematic commonly used to document industrial control logic system. They are called ladder diagrams because they resemble a ladder with two vertical rails which are supply power and as many rungs which are horizontal lines as they are control circuit to represent. Ladder diagrams are used to represent the function of the control circuit and associated device. Pneumatics is a method to transfer energy from one point to other using actuators which are driven by fluids under pressure. Electropneumatics is the pneumatic circuit that can be controlled by electric circuit. Most industries use hydraulic systems that work by using pressurized fluid to power an engine. These hydraulic presses put pressure on a small amount of fluid in order to generate a large amount of power. Fluid Sim is a comprehensive software for the creation, simulation, instruction, and study of electropneumatic, electrohydraulic, digital, and electronic circuits. Fluid Sim is a tool that can help students much understand the operation of pneumatic and hydraulic. Alright, let's jump straight to the discussion. I will talking about part 1, which is input output application. For the first simulation, as you can see, at initial process, the red bulb will be turned on and green bulb is off. When we press the push button 1, which is labeled as PB1, the red button will be turned off and the green bulb will be turned on. But when we press push button 2, which is PB2, the process will be like the initial. It is because PB2 acts as the brake circuit. The second simulation shows us which which is out 110, which represent the output, will energize if input IN1 and IN5 is pressed. Out 110 also can be activated even IN6 or IN7 change state to normally open condition. Out 110 is still energized even IN5 change to normally open because contact relay out 110 and IN1 in line 3 in normally closed condition. If IN4 and IN5 change state to normally closed condition, out 110 also can be activated even IN2 is pressed. Circuit will stop if IN2 and IN5 is in normally open condition. Continuing to the third simulation, this simulation shows that at initial condition, lamp 1 and lamp 2 are in turn on condition. When push button A or push button B is pressed, lamp 1 and lamp 2 will be turned off because all contact relay in normally open condition. If coil relay energized, contact relay will change state from normally closed to normally. I repeat, if coil relay energized, contact relay will change state from normally closed to normally open condition. For the fourth simulation, it shows when X0 is pressed, output Y0 will energize. It also shows that contact relay Y0 in line 1 change state and the timer will be on. In the same time, contact relay Y0 in contact line 3 contact timer relay TO will change to normally closed condition. This circuit will stop after 60 seconds because the timer relay. Repeat. This circuit will stop after 60 seconds because of the timer relay.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Eriazi bin Syamsul Khairi, and I will explain to you about pneumatic circuit and hydraulic circuit. Firstly is pneumatic circuit. From the simulation showed that the initial condition in valve 1 is closed state while valve 3 is in open. Then the simulation shows the valve 3 in open state, push button 1 and push button 2 not pressed, but the cylinder 1 and cylinder 2 retract because cylinder 1 at levels A2. Then for the second circuit, in second condition, push button 1 and push button 2 is pressed, while valve 1 will open while valve 2 will close. It will retract both cylinder. Then for the next simulation, the cylinder 1 and cylinder 2 will move automatically. At cylinder 1, there are two benchmark A1 and A2 which causes valve 2 and valve 4 to extract or retract. At the first condition, cylinder 1 need in extract condition or at levels A1. Push button 1 need to press while push button 2 not press. If push button 2, so the cylinder will move automatically. Cylinder 1 will retract and extract because of level A1. A1 and the actuator of valve 2 and valve 4 is a spring. To stop the operation, we need one of both push button not to press. Then from this simulation is 5/2 way directional control valve detent actuation spring return. There is a spring on the right and left valve. When the valve press, it will back to initial condition. When press detent actuation, it holds the valve from flow back to original condition. If the valve needs to return to initial condition, that actuator needs to be pressed so the cylinder will retract and it will move if the actuator press. Then for hydraulic circuit, the first simulation circuit is 5/3 way directional control valve and lever actuation. For the initial condition, the liquid from tank pump unit flow through valve and back to the tank. Both cylinder will retract. Pump unit supplies a constant volumetric flow. The operating pressure is limited by the internal pressure relief valve and it has two tank connection. The simulation shows when the hand lever actuation press, liquid from pump unit will flow through valve. Double acting cylinder, pressure relief valve and manometer will measure the pressure at connection and liquid will flow back to the pump unit. At pressure relief valve, the normal position is closed and if the opening pressure is reached at P, T will open. Then the pressure drop below preset level, the valve will close again. And lastly, for the last simulation circuit, shows when the actuator in right side valve, the liquid flows from pump unit through valve, double acting cylinder pressure relief valve and flow back to pump unit through pressure relief valve. I think that's all from me and Salam Ramadan. Thank you.
That's all for me, bodoh.
For part 3, question 1. The valve to flow the hydraulic from tank to cylinder must be operated to push the hopper of the dump truck so it can put away the trash out the hopper by using the hydraulic pressure of the cylinder. Then activate the valve that connects the hydraulic flow from the cylinder to tank to operate to return the hopper back its initial by releasing the hydraulic pressure so that the weight of the hopper will push the cylinder back to its original. For the second simulation, this for three-way hand lever valve has three operations. There is apply pressure, release pressure, and initial to hold the operation anytime, so it won't move at certain point. Applying the pressure operation happen by letting the hydraulic into the cylinder. Then we can release the pressure by reverse the flow of the hydraulic out from the cylinder. But we can stop the pressure at any certain point we desire by disconnect the flowing hydraulic so that the pressure will stay the same. And for the last simulation for part 3, we start button X0 is push the oil motor Y0 immediately running as soon as X0 is pressed. Timer relay which set as switch on delay time 000 for 10 seconds. After 10 seconds, X0 press auxiliary motor Y1 will be energized. Timer relay time 001 which been set as switch on delay for 5 seconds after the Y1 running will be start to energizing and activate. The stop button X1 will stop the operation back to its initial when it is pressed. This is because X1 acts as the circuit breaker. As for the conclusion, it is nutshell FluidSim P and FluidSim H is teaching tool for simulating pneumatic and hydraulic basics. This teaching tool helps students understanding how hydraulic and the pneumatic full operate. It also helps students how to draw and simulate the electro-pneumatic circuit and electro-hydraulic circuit diagram. The program will check whether or not certain connection between components are permissible and understand and navigate around the software freely. Pneumatic and hydraulic components are explained by textual description and figure that illustrate underlying working principles. Students understand and design fluid power and programmable logic controller system controller circuit diagram. Thank you.